Hi everyone. In this chapter I am going to introduce the lesson of refraction of light. Sometimes we observe a pencil that appears to be broken when it is immersed in water. We also see in winter the rainbow. Then in this lesson we are going to explain why these phenomena appear to be like this way. First, let's define the phenomenon of refraction. It is a sudden change in the direction of propagation of light when it crosses the surface separating two transparent mediums, like the example of light that crosses from air into water. We see a broken pencil. It appears to be broken since light travels from air into water like this way, so it deviates from its initial trajectory. Let's define the keywords that we will use in this lesson. The plane of incidence is the plane in which we have the incidence. The separation surface is the surface separating the two mediums, for example, air glass. The normal line is perpendicular to the separation surface. The incident ray is the ray that propagates in the first medium. The angle of incidence is formed between the normal line and the incident ray. The refracted ray is the ray that emerges in glass. The angle of refraction is the angle formed between the normal line and the refracted ray. Let's move to the phenomenon of normal incidence. When a ray crosses the surface separating two mediums but it falls on the normal, then it does not deviate. So when the incident ray crosses the normal line, the deviation doesn't take place. If the angle of incidence is 0, the angle of refraction is also 0. Let's define now the index of refraction. Each transparent medium is characterized by an index of refraction, which is n, which is equal to c over v. Then the index of refraction is n. C is vacuum, it's a constant, it's 3 × 10⁸ meter per second, and v is the speed of light in the considered medium. Then if you are going to find the index of refraction of water, for example, you have to use the speed of light in water v. Some examples of the index of refraction, like the index of refraction of air is 1.003, it's approximately 1. In water 1.33, in glass it's about 1.52. If n glass, for example, is greater than n water, then glass is denser than water. We say that glass deviates light more than water. Let's consider the path of light from air into glass. When we compare the index of refraction between air and glass, we find it to be less than n of glass. Then the ray deviates toward the normal. So when light crosses from air to glass, it deviates toward the normal. So from less refractive medium into more refractive medium, the ray toward the normal. Let's define the angle of deviation. When the incident ray deviates, then the angle of deviation d is equal to I1 minus I2. Then it is the deviation angle between the two rays. Now let's consider the path of light from air into one medium. If the ray crosses from air into water, it deviates toward the normal. But let's change the second medium and let's place, for example, alcohol of index of refraction 1.36. Then light deviate more and more. Let's take now the plexiglass, deviate also more and more. Then let's take also the glass of index of refraction 1.55. It deviates more and more and more. Then a medium of index of refraction greater than another index of another medium deviate light more than the second one. Let's consider now the path of light from one medium into air. For example, the path of light from glass into air. We know that the index of glass is greater than the index of air. When the incident ray propagates in glass, it deviates then out of the normal when it propagates in air. Then, in this case, we have n1 greater than n2, thus I1 less than I2, and the angle of refraction is greater than the angle of incidence. Now, what happens if the angle of incidence increases more and more, from more into less refractive medium? In this case, we need to define what we call the limiting angle of refraction, or critical angle, IL, and we need to compare the angle of incidence, I1, with I limiting. We may have one of the three cases: I1 less than I limiting, I1 equal to I limiting, or I1 greater than I limiting. So let's take this example of a ray propagating from glass into air. I1 is less than I limiting, then the refracted ray deviate out of the normal. We have a normal refraction. Now if I1 equal to I limiting, then in this case the incident ray falls on the surface of separation. And if I1 increases more and more till it will be greater than I limiting, then we have the phenomenon of total internal reflection. So when light passes from one medium into a less dense one, we may have one of the three cases. If I1 less than I limiting, we have a normal refraction. If I1 equal to I limiting, the refracted ray falls on the surface. We say that it grazes the surface of separation. And if I1 is greater than I limiting, we will have a total internal reflection in which the angle of incidence is equal to the angle of reflection. Thank you for your patience. This was Hassan Awulsi from ED Plus Center. Thank you.